Today our goal is to solve quadratic equations by factoring. Yesterday we learned how to factor, and we were looking at quadratic expressions. The difference, of course, today being an equation is going to have an equal sign, and our goal today is not just to factor, but we're using factoring as a strategy to solve. Well, what does it mean to solve? To solve, it means to find the values of the variable. These values of the variable are called solutions. So today we want to find solutions. That means values of the variable that make the equation true. For example, in Algebra 1, you solved equations like this. X plus 3 is 8. You found out that x is 5 because if you substitute 5 in for x, you find it's true that 5 plus 3 equals 8. So 5 was that value, right, that you could put into the variable that made the equation true. Okay, today's lesson has a guiding idea. For which values of m and n will the product m times n be equal to 0? Write down as many pairs of m and n as you can. Okay, let's make a chart. If I want to multiply two things to equal 0, I could say, well, 0 times 3 is 0. So is 0 times 11, or 0 times 143.2. Well, so is 0 times a negative number, or a fraction, or even a really weird number. But all of this is true the other way around too, right? 3 times 0 is also 0. 11 times 0 is also 0. Again, same for fractions, decimals, weird numbers, whatever. The guiding idea is this. In order for a product, that means you're multiplying two numbers. In order for a product to equal 0, one of the factors, that is, one of the things you're multiplying together, must be 0. Okay, let's apply that guiding idea to example 1. Example 1 is a quadratic equation that's already factored. And because it's factored, I've got two things sitting next to each other. That means I'm just multiplying x minus 4 times 2x plus 5, and that product is equal to 0. Well, we said the whole idea today is if you multiply two things and they multiply to 0, one of those individual things, one of those factors, must be equal to 0. So either x minus 4 has to be 0 or 2x plus 5 has to equal 0. We can solve these using our knowledge of Algebra 1. And we get two solutions, two values we could substitute in for x that would make the equation true. Well, let's check our answers. If we substitute 4 into the original equation, we get 0 times 13 is 0. Well, that's certainly true. So 4 is a solution. It's a value that makes the equation true. Well, what about this? If we substitute negative 5 halves into the equation, we get some number over here. 2 times negative 5 halves, that'd be negative 5 plus 5 times 0. And no matter what this other number was over here, 0 times any number will indeed be 0. So we solved or found our two solutions. Let's take a look at a different example. This is a quadratic equation that hasn't been factored. So it doesn't look like things being multiplied. It looks like you have three terms that are being added and subtracted together. So if you used your knowledge of Algebra 1, maybe you would try something like this. And maybe you're thinking, well, I can factor, oops, I'm sorry. You would get x squared plus 4x is 45, which maybe you would factor. Then you have two numbers that have to multiply to 45. Well, what are the factors of 45? Could this be 9? No, because 9 plus 4 is going to be 13. 9 and 13 don't multiply to 45. It's pretty messy to try to come up with solutions this way. But we know that if we have two things that multiply to 0, then one of them must be 0. So if we factor this expression, it will look like two things that multiply to 0. We can't factor by grouping because there are 3 terms, so we'll use our big X. We want two numbers that multiply to negative 45 and add up to 4. Let's see, 9 and 5 will work if 5 is negative. So we split this middle term into 9x minus 5x. Now we can factor by grouping. And now we have these factors. X plus 9 times the quantity x minus 5 is 0. Because this looks like something times something else is 0. In order for these two things to multiply to 0, one of the individual factors, either x plus 9 or x minus 5, must be 0. So here are our two solutions, negative 9 and 5. Again, if we want to check, we'd have negative 9 squared plus 4 times negative 9 minus 45. We think that should be 0. Oh yeah, indeed. Go ahead and check it out. It works. And the same would be true over here. We hope that 25 plus 20 minus 45, oh yeah, indeed, that'll give us 0. Okay, last example today. This example is a little different from example 3 because we have terms other than 0 on both sides of the equation. Now, our guiding idea is that if two things multiply to 0, one of them must be 0. We don't have any special guiding ideas about 44. So let's get two things to multiply to 0 by moving all the terms to one side of the equation. And then we need this to look like two things being multiplied, so we'll have to factor. Let's see, 9 and 6 are factors. We'll get a negative 3 if the 9 is negative. So we've just factored the equation so that it looks like two things multiply to 0. And when two things multiply to 0, one of those things, one of those factors must equal 0. And here are our two solutions. I'll leave it to you to check.